Saxon's Trig, lesson 124, and then I guess technically 125, which I'm not going to cover, and I'll explain more after I finish lesson 124, which is about point of division formulas. And if we've reached this far in the book, congratulations us, we've basically done the entire book. So point of division formulas is about the distance between two dots. So if I say, what is the full distance between -6 and 4 on the number line, we would say that that is a distance of 10. And then if I said I wanted to find a third of that distance, we would take 1/3 times the 10 and know that we are traveling 10/3 distance. And if the question said exactly what number does that fall on the number line, we would say, well, we need to add the distance of 2/3, which is 1/3 of it, to the original number, which was the -6, give that a common denominator, and then we would have the spot on the number line. So if here's your -6, here's your 0, here's your 4, that spacing's wrong, then we're basically, -6, we're basically saying that 1/3 of the distance is, so if you picture this split into 3 parts, about right here. So the answer for combining -6 with our 10/3, which is only -3 and something, is still going to fall somewhere in the negative. So all of that makes sense mathematically, visually on the number line, and when I manipulate it. At the bottom of the page, they remind us that when we do, or when we find the distance between the 2 points, we're basically subtracting them. So we're saying 4 minus the -6 gave us the distance of 4 plus 6, which was 10. So originally I was counting it on the number line or doing it mentally with the numbers, but that's actually what I did. When we do the subtracting of the numbers together to find the distance in calculus, that is given to us as a little triangle, which means change in x. And often that side of the triangle is just a little touch darker so that we know we're not talking about a triangle, we're talking change in. So the symbol for calculus that you'll use next year would be the change in x, is when you take your second x and you minus your first x, or your second y and you minus your first y. Then on page 676, they jump into example 1 and they say, find the general equation for the coordinates of point F. So you're looking for F equals, and then a certain coordinate point, basically, that lies 2/5 of the way, so 2/5 is the distance, from point 1 to point 2. Now it's important that I know which direction I'm going because I need to know what my original number is going to be counted as, so that will be point 1. And they say that the coordinate point for point 1 is x1, y1, and for point 2 it's x2, y2. And once they've clarified all that, they then do a mental picture and they draw the 2 dots and they try to show you that they're finding the distance between that is 2/5 of the way. We're going to just jump to our change ins and just do it kind of like we did this one rather than graph a picture. So the change in the x's goes from x2 to x1, we're subtracting those, that gives us the distance. If we multiply that by 2/5, that's giving me how far it's traveling, and then I need to add that to the original, which was x1. And then I want to do the same thing for the y's. I want to do 2/5 y2 minus y1, adding with the original, which was y1. Now, when I distribute this out, it doesn't matter which one I solve. Let me do this one since I've run out of space here. So 2/5 y minus, oops, sorry, I forgot my y2 minus 2/5 y1 plus y1, so that's distributed. These are like terms, so this implies a 1, and since I need to add it, I need a common denominator of 5/5. So this one remains 2/5 y2 minus -2 plus 5, oh, that changes now to positive 3/5 y1. And then since I want to write it in a coordinate point, and I certainly didn't leave enough space or I'll have to write it really small, we're going to combine this in one fraction. Now they already have the same base, so it's easy enough to say 2y squared plus 3y sub 1 all, oh, these were my y's anyway. You know what? Let's just put this where we've got some extra space. Okay, so my y coordinate, which is what I was solving for here, is 2y squared plus 3, oh, not squared, y sub 2, goodness gracious, and y sub 1 all over 5. Okay, and then we get the exact same thing for the x's. See if I can write it correctly this time. 3, oh, it should be this way, 2x sub 2 plus 3x sub 1 all over 5. Okay, now let me triple check. I think I have the order backwards from what they had it. But 3x1 plus 2x sub 2 all over 5, coordinating with 3y sub 1 plus the 2y sub 2. Yeah, that's completely not legible. 2y sub 2 plus 3y sub 1 over 5. There's our lovely coordinate point that they were looking for. Okay, example 2. Find general equations for the coordinates of point F that lies 3/7 of the way from point 1 to point 2. And point 1 is, as we had before, x1, y1, and point 2 is x2, y2, just as we had before. So now we're going to do exactly what we did before. Take our 3/7, subtract our distance to find our difference between x2 minus x1, and we're adding that to the first one, which comes from the p1, so x1. And then I'll leave myself space here, and I'll solve for the x. This time I'll do it backwards. So now we still have our 3/7 with our y2 minus y1, and we're adding that to the y sub 1. Okay, so when we distribute here, 3/7 x sub 2 minus 3/7 x sub 1 plus x sub 1 needs a common denominator for the like terms of 7 over 7. So I keep my 3/7 x sub 2, negative 3 plus 7, 4. So plus 4/7 x sub 1. All right, that would be the first part in the coordinate point, and they all have the same common denominator. So 3x sub 2 plus 4x sub 1 all over the 7. And I'd get the same identical thing except with the y's. So 3y sub 2 plus 4y sub 1 all over the 7. And triple checking their answer, they've got the 4x. So they're always putting the 1 first, then the 2. Doesn't really matter because the order is irrelevant. And that is the coordinate point for that one. Now, moving on to 125. It says, use the graphing calculator to graph. Well, not everyone has one, so we're not going to do that. We're not going to end with lesson 125. We're basically ending with lesson 124. And then it also talks about solution of systems of equations using the graphing calculator, same problem. And then it says roots, which are basically, we already know, answers. But again, that section, if you look at it, is based on the graphing calculator. Now, if you have a graphing calculator, by all means, feel free to look through that lesson, figure out how your graphing calculator works, and solve, and that's absolutely fine. But we are not going to cover it in a separate video, so Saxon's Trig is done.